Hello there and welcome to the Sleepy Space Channel. The universe will end. That much is already written into it, and the only real question left is how. It could freeze, its stars going out one by one, until nothing is left but cold and dark. It could be torn apart, its expansion growing so fierce that it undoes the very atoms. It could fall back together into a single point of fire, or be quietly rewritten in an instant by a change in the nature of empty space itself. Tonight we lay every one of these endings gently side by side and look at each in turn. If you find these slow explorations of the cosmos worth your time, a like or a subscribe helps the channel reach others who do. Thank you for being here. But for the next couple of hours, none of this is anything you need to carry. Every one of these endings lies further away than the mind can travel, and not one of them asks anything of you tonight. Settle in. Let your shoulders soften. Let your breathing slow. Let the day fade away. Let's begin. The universe has a beginning, and almost certainly it has an ending, and the quietly unsettling part is that there is more than one way that ending could arrive. We tend to picture the end of everything as a single event, one final moment written somewhere far ahead of us. The truth is stranger and softer than that. There is not one ending waiting for the universe, but several, and which of them comes to pass depends on facts we are still, even now, slowly measuring. Tonight, we set them beside one another, one after another, and look gently at each in turn. Before any of those endings can be understood, one thing has to be said plainly, because everything else grows from it. The universe is not still. It is expanding, and it is cooling, and it has been doing both since its earliest moments. Space itself is stretching, carrying the galaxies apart from one another, and as it stretches, the average warmth of everything slowly falls. This is the single most important fact about the far future. Nearly every way the universe could end is, at heart, a question about how far that stretching and cooling continues, and whether anything ever interrupts it. It helps to sit with what that expansion really means. The galaxies are not flying outward through some fixed, empty room like fragments from an explosion. Instead, the space between them is growing, swelling gently in every direction at once, so that distant galaxies drift apart the way two marks on a rising loaf of bread move away from each other as the dough expands. Nothing is racing through space. Space itself is the thing that grows. And a universe that grows and cools without limit is a universe that must, in time, become something very different from the bright and crowded place we know tonight. To follow where that leads, we need one more idea, and it is a gentle one despite its reputation. That idea is entropy. Entropy is simply a measure of how spread out and how disordered energy has become. When energy is concentrated and organized, things can happen with it, the way a boulder at the top of a hill can roll down and do work along the way. When energy is spread thin and evenly, nothing can happen, the way that same boulder resting at the bottom of a valley has nowhere left to fall. The universe began in a state of unusually gathered, orderly energy, and ever since, that order has been slowly, steadily unwinding. This slow unwinding is what gives time its direction. You may have noticed that the past and the future do not feel the same. A cup can fall from a table and shatter, but the pieces never gather themselves back up onto the table on their own. Warmth flows from a hot drink into a cold room, never the reverse. In every case, the change runs one way, from more gathered to more spread out, from more ordered to less. That one-way flow is the arrow of time, and it points, always, toward greater entropy. The far future is simply the place where that arrow has traveled as far as it can go. Every ending we will explore tonight is, in the end, a story about entropy. Some of them are the slow and total triumph of it, the universe running all the way down until there is nothing gathered left anywhere. Others are events that cut the story short before entropy has the final word, folding the universe back on itself, or tearing it apart, or quietly rewriting it from within. But entropy is the current beneath them all, the reason the universe cannot simply stay as it is forever. Now, which of these endings actually comes to pass is not yet settled, and it rests on three things, three quantities we are still learning to read. Everything in the whole long story ahead turns on them, so it is worth naming each one softly before we begin. The first is dark energy. Dark energy is the name we give to a faint pressure that fills all of empty space and pushes the expansion of the universe to speed up rather than slow down. It is the largest single ingredient in the cosmos, and also the least understood. The most important question about the entire future of everything is whether this dark energy holds perfectly steady, or slowly weakens, or slowly strengthens over the ages. A steady, constant dark energy points toward one kind of ending. A strengthening one points toward another, far more violent. A weakening or reversing one opens the way to a third. We simply do not yet know which of these is true, and so the universe keeps its own ending partly hidden, even from those of us trying hardest to see it. The second quantity is the shape of space itself, what we call its geometry, or its curvature. Space can, in principle, be curved in one of a few ways over the largest scales. It could be curved back on itself, closed like the surface of an enormous sphere. It could be curved outward, open and saddle-shaped. Or it could be flat, in the sense that the ordinary rules of geometry hold true even across billions of light-years. When we measure it, the universe comes out astonishingly close to flat, balanced on a fine line between the closed and the open. This flatness quietly shapes which endings are likely, because only a closed universe could one day collapse back on itself under its own weight. The third quantity is the most subtle, and we will return to it much later tonight. It is the stability of empty space, the question of whether the vacuum, the seemingly featureless nothing between the stars, is resting in its truly lowest possible state, or only in a temporary one. If it is truly lowest, the universe is stable in its foundations. If it is only temporary, then a certain sudden kind of change becomes possible, one that does not wait on expansion or gravity at all. For now, it is enough to know that this third lever exists, quietly, beneath everything else. So the whole future of the cosmos balances on these three things, and all three are still being measured, still partly unknown. There is something almost tender in that thought. The universe does not announce its own conclusion. It leaves the ending written in faint clues, in the speed of distant galaxies and the values of tiny particles, and it lets those of us who are curious work slowly toward the answer, knowing all the while that the answer lies further away than any of us can truly picture. It is worth preparing the mind, too, for the kind of time we will be speaking of tonight, because it is unlike any time we ordinarily meet. The span since the beginning of the universe, some 13.5 billion years, feels enormous to us, and it is. Yet against the endings ahead, it is almost nothing, the merest opening note. We will speak of stars that burn for trillions of years, of remnants that cool for far longer, of black holes that take spans written as a one trailed by dozens and then 100 zeros to fade. These are not numbers the mind can truly hold. They are better felt as depths, as a sense of time opening downward and downward, far past anything a life or a world or even a galaxy could measure. Let the exact figures slide away as they come. What matters is only the feeling of a future so long that the whole bright history of everything we know is a single early morning within it. And that distance is worth holding on to from the very start, because it changes how all of this feels. Not one of the endings ahead of us is near. Every one of them lies further into the future than the entire age of the universe so far reaches into the past. The stars have not begun to tire. The sky above you tonight is still full. We are living, if anything, in the bright early morning of the cosmos, and the endings we are about to explore are horizons so distant that they are less a fate bearing down on us than a feature of the far country we can only describe from afar. Keep that in mind as we go. We are not walking toward an edge. We are only learning the shape of the whole map. It is worth saying a little more about that cooling, because it is easy to picture the early universe as fiery and to forget how far it has already fallen. In its first moments, the whole of space was searing, hotter than the center of any star, filled everywhere with a dense glow. As space expanded, it cooled, and that ancient glow cooled along with it, stretched thinner and thinner by the growing space, until today it lingers only as a faint whisper of warmth filling all of the sky, a mere few degrees above the coldest temperature there can be. That gentle background warmth is the oldest light there is, the cooled remnant of the beginning, and it is still falling. The universe has been cooling for the whole of its life, and it will go on cooling, and that unbroken slide toward cold is the plainest sign of where it is bound. The flatness of space deserves a moment too, because it is a delicate and surprising thing. When we say that space is flat, we mean that over the largest reaches the familiar rules of geometry hold true, that the angles of an enormous triangle drawn across the cosmos would add up just as they do on a tabletop. In a closed universe, those angles would sum to a little more, and in an open one, a little less. We can actually measure this using that oldest light, and the answer comes out flat to within a very fine margin. Why the universe should be balanced so exactly on that line, curved neither inward nor outward, is itself one of the quiet puzzles of cosmology, and it bears directly on how everything ends. And there is the deeper question of why the universe began so orderly at all, with its entropy so low, because that gathered beginning is the very thing that makes the long unwinding possible. A universe that started, already spread out, and even would have had no story to tell, nothing to fall from, no arrow of time at all. Ours began smooth and gathered in a particular way, wound up like a spring, and everything that has happened since, every star and world and living thing, has been powered by the slow release of that winding. The ending, in every version we will explore, is simply the spring reaching the end of its unwinding, the last of that first order finally spent. With the ground laid, we can begin to lay the endings side by side. We will start not with a dramatic finish, but with the slow, gentle process that is already underway, the process that sets the stage for everything else, and then move outward from there into the stranger and grander possibilities. Each one is its own quiet country. Each one is worth seeing on its own terms. And each one, in its way, ends in a kind of stillness. Long before any grand ending arrives, there is a change already in motion, and it is one we can measure directly tonight. The expansion of the universe is not gentle and steady in the way it once was. It is speeding up. The galaxies are drifting apart faster and faster as the ages pass, and that single fact, quiet as it sounds, reshapes the far future more than almost anything else. It means the universe is slowly emptying, and the sky, over time, is going dark. To understand why, imagine the light leaving a distant galaxy right now, setting out across the space between us. As that light travels, the space it must cross keeps growing. If the expansion were slowing, the light would always, eventually, complete the journey. But because the expansion is quickening, there comes a distance beyond which space grows faster than the light can cross it. Light setting out from a galaxy past that distance will never reach us. It falls behind forever, carried away by the swelling of space itself. There is, in other words, a horizon around us, not a wall in space, but a limit set by the expansion, beyond which things recede too quickly to ever be seen. And galaxies are crossing that horizon all the time. One by one, over the ages, the galaxies we can see tonight are being carried past it, not by moving anywhere themselves, but simply because the space between us and them keeps growing until their light can no longer bridge the gap. When a galaxy crosses that line, it does not vanish in a flash. It reddens and dims and slows, its light stretched thinner and thinner until it fades quietly from view and is gone. The number of galaxies at stake here is hard to hold in the mind. When we look out with our finest instruments, we find that the observable universe holds something close to 2 trillion galaxies, each one a gathering of many billions of stars. Nearly all of them are already beyond our reach in the sense that matters most. We can still see their ancient light, but the expansion has already carried them so far and set them receding so quickly that we could never travel to them and never send any message that would arrive. Most of the galaxies in the night sky are, in truth, already farewell. We are seeing portraits of places we can never touch. As the ages pass, this emptying deepens. The galaxies beyond our own small neighborhood will continue to recede, redden, and fade until the general sky holds nothing at all beyond our local shore. What remains bound to us is a modest gathering of galaxies held together by their own gravity, a company called the local group. Gravity within this group is strong enough to resist the expansion, so these galaxies will not be carried away. They stay together while everything else departs. But everything beyond them slips, over time, past the horizon and out of sight. And the local group itself will change. Its 2 largest members, our own galaxy and a great spiral neighbor drifting steadily toward us, are on a slow course to meet. Across billions of years they will approach, pass through and around one another, draw apart, and fall back together, their stars so widely spaced that almost none will ever collide. Gradually, over an enormous span, the 2 great spirals will settle into a single, rounder gathering of stars, an elliptical galaxy formed from the merger of both. The smaller members of the local group will, in time, be drawn in as well. What was once a company of galaxies becomes one. Picture, then, a world in that far future galaxy, tens of billions of years from now, with someone upon it who looks up and studies the sky. They would see their own stars, gathered close, a single island of light. And beyond that island, in every direction, they would see only darkness. The other galaxies would all have receded past the horizon, their light stretched away to nothing long before. There would be no smudges of distant light to hint that other galaxies had ever existed. Even the faint background glow left over from the beginning of the universe would have faded and stretched beyond any hope of detection. Consider what that means for the astronomer of the far future. Looking out at a single galaxy surrounded by perfect dark, with no other galaxies to compare against, and no leftover glow from the beginning, they could study the sky as carefully as we do and reach an entirely reasonable and entirely mistaken conclusion. They could decide that their island of stars was the whole of the universe, unchanging and alone, with no expansion, no other galaxies, and no fiery beginning at all. The evidence that tells us our own cosmic story would, by then, have quietly slipped away. The universe will have hidden its own history. There is something worth pausing on in that. It suggests that we are living at a rare and gifted moment. We are late enough that stars and galaxies have formed and settled into their long, luminous lives, and early enough that the whole crowded universe is still visible, still readable, still full of the clues that tell us where it all came from. 1 trillion years from now, that fullness will be gone. The best time to look out and see the entire universe in its richness is not some distant future. It is now. None of this slow emptying is itself an ending, exactly. The galaxies that fade from our view do not cease to exist. They carry on, out beyond the horizon, living their own long lives in isolation. What ends, for any given observer, is the ability to see beyond one's own island. The universe does not so much disappear as become private, each bound patch of it alone with itself, cut off from all the rest by the widening dark. This is the stage upon which the true endings play out. It is the emptying room in which the last acts unfold. It is worth dwelling for a moment on just how gradual this emptying is, because the slowness of it is part of its gentleness. The galaxies do not rush from view. Over spans of many billions of years, they redden and dim by degrees, their light stretching further and further toward the invisible as the space between grows. A civilization could watch the same distant galaxy for the whole of its history and see it fade only a little, so slow is the process on any scale a living thing could know. The sky does not go dark in a night or an age, but over stretches of time longer than the universe has yet existed. What we are describing is less an event than a tendency, a direction the sky is quietly leaning out toward a deeper and deeper isolation. There is a particular kind of loneliness written into this far future, and it is worth naming softly, without letting it weigh too much. The observers of that distant age would be islanded not only in space but in knowledge. Every clue that tells us our own cosmic story, the receding galaxies, the faint background glow of the beginning, the very evidence that the universe expands and once was hot and dense, would by then have slipped beyond any instrument's reach. They would live in a true and unbroken dark beyond their own shore, with no way to know what lay past it, or that anything ever had. The universe will not only empty, it will forget, and it will teach its last observers to forget as well. And that is exactly why the fullness of our own moment feels less like a coincidence and more like a gift held out for only a while. We are here in the one long chapter, when the whole of the universe is still legible, when the sky is still crowded, and the beginning still leaves its trace, and the galaxies have not yet drifted past the horizon. The reading of the cosmos is a thing that can be done now and could not be done then. Whatever else the emptying takes, it cannot reach back and take this, the bright and readable sky we happen to have been born beneath. So we hold that gift lightly and gratefully as we go on, aware that the emptying is real but unhurried, and that it sets the stage without ever rushing it. The sky will darken over spans no living thing could follow, and long before it does, everything else in our story will already have unfolded within it. The emptying is the slow backdrop against which the true endings play, and it asks nothing of us tonight but to notice, once, how full and bright the sky above still is. Within our own island of stars, and within every other isolated island scattered through the emptied universe, the same long process will continue. The stars themselves will age. The gas that makes new stars will run low. The light will slowly dim. What happens to a single galaxy, left alone in the growing dark, is the story of the Big Freeze, and it is the mainstream expectation for how the universe winds down if dark energy holds steady. It is where we turn next, gently, as the sky continues to empty around us. The most likely ending, the one the universe seems most set upon if dark energy holds steady, is not a bang or a crush at all. It is a slow fade. It is called the Big Freeze, or sometimes the heat death, and it unfolds over stretches of time so long that the entire age of the universe so far is barely the first breath of it. This first stretch of that fade is the gentlest chapter to picture, because it is simply the story of the stars, one by one, going out. Stars are not eternal, though they can seem so on the scale of a human life. Each one is a balance, a slow burn of light against the pull of its own gravity, and each one is spending a fuel that will not last forever. Every star that shines is drawing down a finite supply, and when that supply is gone, the star can no longer hold itself up in the same way, and its life as a source of light comes to an end. The universe has been making stars for billions of years, but it cannot do so without limit, because the raw material is not endless. That raw material is gas, mostly the light gas left over from the beginning, gathered by gravity into clouds that collapse and ignite. Every time a generation of stars is born, some of that gas is locked away forever inside dense stellar corpses that never give it back. Little by little, the reservoir of star-making gas is drawn down. And so, across the ages, the rate at which new stars form does not hold steady. It falls. In fact, if we look carefully at the history of the cosmos, we find that the great age of starbirth has already passed. The universe made stars most furiously long ago, and ever since, the pace has been in a long, slow decline. Follow that decline far enough forward, and it reaches its natural end. Somewhere on the order of 100 trillion years from now, the gas will have grown too thin, too spent, too scattered to gather and ignite. The last new star will form, take its place in the sky, and after it, no more. There will be no fresh light kindled anywhere. From that point on, the universe holds only the stars already burning, and they will burn on for a while, and then they too will fade, and there will be nothing to replace them. Now, not all stars age at the same pace, and this is where the fade grows long and quiet. The largest, brightest stars live fast and die young, spending their fuel in a matter of millions of years. But the smallest stars, the cool and modest red dwarfs, are the most patient burners in the universe. They hold far less fuel, but they spend it so slowly, so frugally, that a single red dwarf can shine steadily for trillions of years, outlasting a star like our own sun many times over. They are the ones who will keep the last watch. Long after every brighter star has died, the red dwarfs will still be glowing, dim and red and enduring, in a sky otherwise going dark. But even patience runs out. One by one, over spans that beggar the imagination, the red dwarfs will cool and dim as well. Their light will slide from red toward the faintest ember tones, and then toward nothing at all. The universe will pass out of the age of true starlight and into a long twilight, lit only by the last cooling embers of stars that have already, in every meaningful sense, died. There will still be points of faint warmth here and there, but the bright, generous light we know tonight will be a thing of the ancient past. When the last star finally ceases to shine, the universe enters what is often called the degenerate era, and it is a place worth describing gently, because it is where much of eternity is spent. The universe of that age is not empty, but it is populated no longer by living stars, only by their remains. Three kinds of remnant fill the dark: white dwarfs, neutron stars, and black holes. These are the dense corpses left behind when stars can no longer hold themselves up, and each is stranger than the last. The white dwarfs are the most common. A white dwarf is the leftover core of a star much like the Sun, an object about the size of the Earth, but holding much of the mass of a whole star, so tightly packed that a spoonful of its material would weigh as much as a small mountain. When a star like the Sun exhausts its fuel, it sheds its outer layers gently and leaves this hot, dense core behind. At first, the core glows fiercely white from the heat of its making. But nothing feeds it any longer, and so, across the ages, it does the only thing it can. It cools. Over spans of time far longer than the current age of the universe, each white dwarf will slowly radiate its warmth away into the dark and darken, cooling from white through dimmer and dimmer colors, until it becomes a cold, dead cinder, a black dwarf. It is worth pausing on that idea because it says something quiet about how young the universe still is. A black dwarf, a fully cooled white dwarf, does not yet exist anywhere in the cosmos. Not one. The universe has not been dark and old for long enough for even a single white dwarf to finish cooling. Every white dwarf that exists is still warm, still glowing faintly, still on its way. The first true black dwarf lies so far in the future that from where we stand, it has never happened at all. When we speak of the sky of embers, we are speaking of a chapter the universe has not yet even begun to write. The neutron stars are rarer and stranger still. Each one is the collapsed heart of a star far more massive than the Sun, its core crushed so completely that a whole star's worth of material is packed into a sphere no wider than a city. They spin, some of them very fast, and glow faintly, and they too will cool and dim across the ages, fading into the general dark along with everything else. And then there are the black holes, the third kind of remnant, which will come to matter more and more as time goes on, and which will have the whole of the next chapter to themselves. Around all these dead and dying stars, the planets remain. Worlds that once basked in starlight now drift cold and dark around cooling cinders, or are cast loose entirely by slow gravitational encounters to wander alone through the space between. Now and then, across enormous stretches of time, two objects still pass close and swing around one another, or a wandering world is captured, or a rare, slow collision stirs the dark. But these are scattered incidents in a deepening stillness. The overall motion of the degenerate era is toward cold, toward separation, toward quiet. The lights are going out, one by one, and there is nothing left to light them again. It is worth lingering on the red dwarfs a little longer, because they are the patient heart of this whole chapter. A star like the Sun burns only the fuel near its core, and then, in time, changes and dies, leaving much of its material untouched. A red dwarf, by contrast, is small and thoroughly stirred within, its contents slowly circulating, so that nearly all of its fuel is carried down to the burning center and used. It spends everything it has, and it spends it with extraordinary thrift. That is why a modest red dwarf can shine for trillions of years, 10 times over and more the lifetime of the Sun. In the long dimming of the universe, they are the last lamps left burning, tending a light that fades so gradually it seems almost unwilling to end. There are fainter objects still that never quite became stars, and they too have their place in this fading. Scattered through the darkening universe are bodies larger than any planet but too small to have ever kindled true and steady starlight, dim and cooling almost from birth. They drift through the long twilight, giving off only the faintest warmth, and over the ages, that warmth fades as well. Now and then, across enormous spans, two such failed or spent objects may slowly drift together and merge, and for a brief while, their combined mass rekindles a small new light, a last flicker of true fusion in a sky that has nearly forgotten it. These are rare and fleeting sparks, quickly spent, small punctuations in a deepening quiet. Even the white dwarfs change in ways worth picturing gently as they cool. As one of these dense cinders gives up its heat over the ages, the material within it slowly settles and orders itself, hardening from within, so that the once molten core grows firm and structured as it chills. The star becomes, in a sense, a single enormous, ordered solid, cooling toward the temperature of the space around it. It is a quiet fate for what was once a blazing sun, to firm slowly into a cold and structured sphere and drift onward in the dark, its light long since given away to the widening night. And yet there is nothing frightening in this when you sit with it. It is the natural old age of a universe that has spent its youth generously making light. The stars are not being taken. They are simply finishing, each in its own time, having done what stars do. What follows the last starlight is not violence but silence, and it is to the long, patient reign of that silence and the dark giants that come to rule it that we turn next. Given enough time, and the universe has more time to give than we can truly conceive, the black holes come to inherit the cosmos. After the last stars have died and their remnants have begun their long cooling, gravity keeps doing its patient work, and the darkest and densest objects of all rise to become the dominant structures in the universe. This is the black hole era, and it is the longest chapter in the whole story of the Big Freeze, so long that everything that came before it, all the ages of stars and galaxies and light, is only a brief prologue by comparison. To reach that era, though, ordinary matter may first quietly disappear, and by a route that surprises many people when they first meet it. There is a possibility, still unproven but taken seriously, that the protons at the very heart of every atom are not perfectly stable. A proton is one of the building blocks of all ordinary matter, sitting in the nucleus of every atom in your body and in every star and world. It seems utterly permanent on any timescale we could ever test. But some of our deepest theories suggest that a proton might, very rarely, over spans of time almost beyond writing down, come apart on its own, dissolving into lighter particles and light. If protons do decay, then across an enormous stretch of time, all the ordinary matter left in the universe, every cold white dwarf, every neutron star, every wandering frozen world, would slowly evaporate from within. Not by fire, not by any event, but simply by the patient dissolving of the particles that compose it, atom by atom, until the solid corpses of the stars had thinned away into a faint drift of radiation and stray light particles. Whole dead stars would quietly cease to be, over ages so long that the process would be imperceptible at any given moment, yet complete in the end. Whether protons decay at all is one of the open questions of physics, and the two possibilities lead to somewhat different timelines. If protons decay, ordinary matter fades first, and the black holes are left as almost the only structures remaining. If protons do not decay, then the cold remnants endure far longer and are gathered over even greater spans into black holes by the slow choreography of gravity. Either way, the ending rhymes. Either way, the universe arrives at an age in which the black holes stand nearly alone. And a black hole, for all its reputation, is not truly forever either. This is one of the most beautiful and quietly strange facts in all of physics. A black hole, which seems like the most permanent object imaginable, a place from which nothing escapes, does in fact very slowly leak. At its edge, empty space itself behaves in such a way that the black hole gives off an almost imperceptibly faint warmth, a whisper of light and particles drifting away from the boundary. It is far too dim to notice in any black hole that exists today, drowned out entirely by the warmth still filling the universe. But it never stops. Because of that faint leaking, a black hole slowly loses mass over time. And here the process has a curious turn. The smaller a black hole becomes, the faster it leaks, and the warmer it grows. So the shrinking speeds up as it goes. For most of a black hole's life, this is unimaginably slow, a barely there trickle across ages. But near the very end, as the black hole grows small, the trickle quickens into a final soft flare, a last release of energy, and then the black hole is simply gone, having returned all of itself to the universe as light. The timescales here are the longest we will name tonight, and they are worth speaking slowly. A black hole of modest size, left alone to leak, would take a span of years written as a 1, followed by dozens upon dozens of zeros to fully evaporate. The largest black holes of all, the giants that sit at the centers of galaxies and hold the mass of billions of suns, would take a span written as a 1 followed by something like 100 zeros. These are numbers so large that they are not really quantities anymore, but ideas, ways of gesturing at an emptiness of time that has no comparison in ordinary life. And yet, at the far end of even those numbers, the last black hole finishes leaking, gives its final flare, and vanishes. When the last black hole has evaporated, the universe holds no stars, no worlds, no dead remnants, and no black holes. It contains only a thin and cooling haze, a scattering of light and stray particles drifting ever farther apart in an ever-growing dark. There are no structures left, nothing gathered, nothing bright, nothing that could be called an event. This is the state the whole long fade has been approaching all along, and it has a name. It is called heat death, and it is the final condition of the universe in the Big Freeze. Heat death is often misunderstood, because the word death makes it sound violent, and the word heat makes it sound hot. It is neither. Heat death is best understood as sameness, as evenness carried to completion. In this final state, energy has spread out so thoroughly and cooled so far that nothing anywhere is warmer or colder, faster or slower, higher or lower than anything else. Energy still exists, but it is smeared so evenly across everything that it can no longer flow from one place to another, and so it can no longer make anything happen. Recall the boulder from the beginning of tonight, resting at last at the bottom of the valley, with nowhere left to roll. Heat death is the whole universe come to rest in the valley floor. And when nothing can happen, something quietly profound follows. Time itself begins to lose its meaning. Time, as we experience it, is marked by change, by one moment differing from the next, by things happening in an order. In a universe where nothing gathers, nothing moves, and nothing changes, there is no longer anything to mark one moment as different from another. The clock does not stop exactly. It simply has nothing left to measure. This is why the final chapter of the Big Freeze is sometimes called the Dark Era, and why it has no defined ending. It is not a wall the universe strikes. It is a stillness the universe approaches forever, drawing nearer and nearer, without ever fully arriving. It is worth holding this final state gently, because it can sound bleak, and it need not. The universe does not suffer in heat death. There is no struggle in it, no loss felt, no cold endured by anyone. It is simply the natural resting place of a cosmos that spent its long life spreading its energy around as generously as it could. If anything, there is a strange peace in it, the peace of a thing that has finally become completely even, completely quiet, completely at rest. The universe, having done everything it could do, at last does nothing at all, and holds that stillness without end. There is a subtle reason why the black holes must wait so long before their leaking can even begin in earnest, and it is a lovely detail of this far future. The warmth that a black hole gives off is fainter and colder the larger the black hole is, colder even than the faint background warmth that still fills the universe today. And an object cannot lose heat to surroundings warmer than itself. So for a long age, while the universe still holds that leftover background glow, the great black holes actually take in more warmth than they give away, and slowly grow rather than shrink. Only after the universe has expanded and cooled far enough, until the background is colder than the black holes themselves, can the leaking finally win out, and the long evaporation truly begin. The black holes must wait for the universe to grow cold around them before they can start to fade. It is worth holding in mind, too, what these objects actually are in the deep future, because they are the last great gatherings of everything that came before. Into the black holes has fallen the material of dead stars, the remains of worlds, the scattered dust of galaxies, all of it drawn together and folded away behind a boundary from which nothing returns. In a real sense, the black holes of that era are the universe's memory, holding the mass of everything that ever shone. And when they leak it slowly back out as faint light over those unthinkable spans, they are returning that gathered substance to the universe at large, spreading it thin again, undoing the last of all the gathering that gravity ever did. The final evaporation is the universe giving back everything it once collected. When at last the largest black hole reaches the end of its leaking, its shrinking has by then quickened into a final soft flare, a last release of everything it held, dimmer and gentler than any explosion but complete. And then it is simply gone, and with it goes the last structure the universe will ever contain. After that flare, there are no more objects anywhere, no gathered things, only the thinning drift of light and stray particles spreading outward without end. That final flare is, in a sense, the last event the universe will ever have, the last time anything happens at all, before the long changelessness settles in for good. There is one last curious thought that some who study this era allow themselves, and we touch it lightly, as a piece of open wonder rather than any kind of claim. In a universe of endless time and faint random stirrings, some wonder whether, once in an unthinkable while, the drifting haze might by pure chance flicker into some briefly ordered pattern, a momentary shape gathered from the evenness, before smoothing away again. No one knows if this is truly so, and it is best held loosely, as one of the odd and unresolved musings at the very end of thought. But the main story is simpler and quieter than that. The Big Freeze ends not in fire and not in a crush, but in a long, even, boundless calm. And having followed the universe all the way down into that calm, we turn now to a very different kind of ending, one where expansion does not fade gently at all, but wins so completely that it tears the universe apart. The Big Freeze assumes that dark energy, the pressure pushing the expansion to accelerate, holds steady across all of time. But we do not actually know that it does. And if dark energy behaves differently, if it grows stronger as the ages pass, rather than holding constant, then the universe meets a very different ending, one that is quick and definite, where the freeze was slow and endless. This ending is called the Big Rip, and it is the story of expansion winning so completely that it pulls everything apart, from the largest structures down to the smallest. To understand it, we have to look a little more closely at dark energy itself. Dark energy fills all of space with a faint outward pressure, and the way we describe its behavior comes down, in essence, to a single number that captures how its pressure relates to how densely it fills space. If that number sits at one particular value, dark energy stays constant forever, and the universe drifts toward the Big Freeze. But if the number lies just past a certain threshold, into what is called the phantom regime, then something remarkable happens. As space expands, the dark energy within it does not thin out or hold steady. It strengthens. The more space grows, the harder the dark energy pushes, and the harder it pushes, the faster space grows. That is a runaway. In the phantom case, expansion feeds on itself, quickening without limit, and the horizon that surrounds every observer, the distance beyond which things recede too fast to be seen, does not merely sit still. It shrinks. It draws inward. The repulsion that today acts only across the widest gulfs, between galaxies far removed from one another, begins to reach down to smaller and smaller scales, closing in over time until it overwhelms the ordinary bonds that hold things together. And so the tearing begins, and it happens in a strict order, from the biggest things to the smallest. First, the great clusters and superclusters of galaxies, the largest bound structures in the universe, are pulled apart, their member galaxies stripped away from one another and carried off into isolation. Then, as the horizon shrinks further, the individual galaxies themselves begin to come undone. The stars that circle within each galaxy, held in their long orbits by gravity, feel the growing push overcome that gravity, and the galaxy disperses, its stars scattered outward, no longer bound to spiral together. Then the tearing reaches inward again, to the scale of single stars and their worlds. Solar systems are unbound. Planets, which have circled their stars faithfully for ages, drift free and are carried away, the gentle grip of gravity finally broken by the swelling of the space between star and world. And still the process quickens, because in the phantom scenario there is a definite finish line rushing closer, a specific moment toward which everything accelerates. In the final stretch before that moment, the tearing grows almost too fast to picture. Stars themselves are pulled apart, unable to hold their own material against the expansion now working even at their scale. Worlds come undone. And in the last fraction of a second before the end, the process reaches all the way down to the smallest scales of all. Molecules are pulled apart. Then atoms. Then the tiny nuclei at the hearts of atoms. And at the very last instant, some think, space itself may be shredded, torn beyond any structure at all, as every distance in the universe races toward becoming infinite at once. That is the defining difference between the Big Rip and the Big Freeze. The freeze has no end. It only approaches stillness forever. The rip has a precise conclusion, a single future moment at which the distance between everything, everywhere, becomes unbounded. It is an ending with a date, even if that date lies far ahead. And in the scenarios where the rip applies, that ending, while distant, would come far sooner than heat death ever could. Rather than the almost limitless spans of the Big Freeze, the Big Rip would arrive within a span of time measured in tens of billions of years. Longer than the universe has yet existed, but near, by comparison, to the endless ages of the slow fade. Now, is the Big Rip actually our fate? The honest answer is that no one knows, and the reason is exactly the reason we keep returning to. It all comes down to dark energy, and to whether that single describing number holds constant or drifts into the phantom regime. If dark energy is truly constant, there is no rip. The universe fades gently instead. If it strengthens over time, the rip becomes not just possible, but inevitable. Everything hinges on measuring dark energy precisely enough to tell the difference, and that measurement is genuinely hard. What makes this more than an idle possibility is that our best recent efforts to weigh dark energy have offered a faint, unresolved hint that it might not be perfectly constant after all. Enormous surveys, mapping the positions of many millions of galaxies across billions of years of cosmic history, have begun to suggest that the strength of dark energy may have changed subtly over time, rather than holding fixed. This is not settled. It is a whisper in the data, still being checked and rechecked, and it could yet fade away as measurements sharpen. But it is enough to keep the Big Rip a living possibility, one of the real branches the future might take, rather than an idea we have set aside. It is worth noting, too, that if dark energy is changing, it need not be changing toward the phantom regime. It might be weakening instead, in which case the universe would drift toward yet another kind of ending entirely, one where expansion loses its grip and gravity is given room to reassert itself. That possibility leads us gently toward the next ending in our catalogue. But the Big Rip stands as the scenario where change runs the other way, where the push that today only nudges the farthest galaxies grows until it can undo an atom. There is a way to sit with even this ending calmly, despite the drama of its picture. The Big Rip, described from a distance, is simply the universe following one particular version of its own nature all the way to the end. It is expansion carried to completion, the same gentle swelling that today merely carries galaxies apart, extended without limit until it carries everything apart. Nothing in it is cruel. It is a process, running its course, over spans so long that not one star we know tonight would live to see even its beginning. Held at that distance, the great tearing becomes not a horror, but a possibility, one shape the far country might take, described softly and set down beside the others. It helps to picture the final stretch of the Big Rip a little more closely, because the ordering of it is part of what makes it so orderly rather than chaotic. In the last long while before the end, the great clusters of galaxies would already have been undone, and the galaxies themselves would be coming apart. Then, in the final stretch of months, our own gathering of stars would loosen and disperse, the familiar band of light unwinding into the dark. In the last hours, any planetary systems still holding together would let their worlds drift free. In the final minutes, the worlds themselves would come apart, and in the last fraction of a second, the atoms. Each scale would let go in its turn, gently and in order, like a knot untying itself one loop at a time, from the largest loop to the smallest. What decides whether any of this happens is a single quantity that describes how dark energy behaves, and it is balanced on a knife's edge that we are still trying to measure. If that quantity holds at one particular value, dark energy stays constant and there is no rip at all, only the slow fade. If it strays past that value into the strengthening regime, the rip becomes not just possible, but certain, its finish line set. The whole difference between an endless gentle cooling and a definite tearing comes down to which side of a single fine line the true nature of dark energy falls on. We do not yet know, and that not knowing is honest, and it is why this ending stays firmly among the possibilities, rather than being ruled in or out. There is even a strange gentleness to be found in the Big Rip, once its drama is set at its true distance. For nearly the whole span leading up to it, life in such a universe would go on entirely unchanged, the stars shining, the galaxies turning, nothing amiss. Only in the final stretch, brief compared to all the ages before it, would the tearing become noticeable at all, working its way down through the scales in order. And by then it would be so far in the future that no star or world we know tonight would remain to witness it. The great tearing, for all the force of its picture, would arrive after a piece longer than the entire history of the universe so far. And that is how we leave it, for now, having laid it in its place in the catalogue. The freeze fades, the rip tears. Both let expansion have the final word, in their different ways. But there is a third path, an older idea, in which expansion does not win at all, in which the universe stops reaching outward and begins, instead, to fall back toward itself. To that long fall we turn next. For much of the last century, when people imagined the end of the universe, this is the ending they pictured. It is called the Big Crunch, and it is, in the simplest terms, the Big Bang run backwards. In this scenario, the universe does not fade forever, and it does not tear itself apart. Instead, its outward expansion slowly halts, reverses, and turns into a long fall inward, until everything that has spread apart comes back together into a single dense and glowing state, much like the one from which it began. The idea has a natural appeal because it gives the universe a symmetry. If the cosmos began in a hot, dense state and then expanded, then perhaps it might one day cease expanding and return to a hot, dense state at the close, the whole history a single arc rising and falling. For a long time, this seemed not only elegant but likely, and whether it happened came down to a simple-sounding question of weight. If the universe held enough matter and energy, then gravity, pulling everything together, would eventually be strong enough to overcome the expansion, halt it, and reverse it. If it held too little, the expansion would coast onward forever. The whole fate of everything seemed to balance on how much the universe weighed. For a big crunch to happen then, gravity must, in the end, win. That is most natural in a closed universe, one curved gently back on itself, holding enough total matter and energy that its own gravity can eventually rein the expansion in. But there is another way it could happen too, and it ties back to the thread running through the whole night. If dark energy, rather than holding steady or strengthening, someday weakens and then reverses, turning from a push into a pull, it could draw the universe back together, even if it would not have collapsed on its own. In that case, the very thing driving the expansion today becomes the thing that ends it. Suppose it happens. Suppose the expansion slows, stops, and quietly turns around. What would that long fall look like? At first, almost nothing would seem to change, because the reversal would be so gradual. But over immense spans of time, the galaxies that are now drifting apart would slow their retreat, come to a halt, and begin, ever so slowly, to approach one another again. The light reaching any observer from distant galaxies, which today is stretched toward the red by the expansion, would begin instead to be compressed toward the blue as those galaxies drew nearer. The sky itself would carry the sign of the turning. As the fall continued and deepened, the universe would grow steadily warmer and more crowded. The galaxies, no longer held apart, would begin to merge into one another, their long separations closing. The gentle dark between the stars would slowly brighten as everything pressed together. Where the big freeze led toward cold and emptiness, the big crunch leads the other way entirely, toward heat and density, toward a sky that grows brighter and hotter rather than darker and colder. The universe would be retracing its own first moments, but in reverse, climbing back up the slope it once descended. In the final stages, the crowding would become extreme. Stars and worlds and the merged remains of galaxies would be pressed closer and closer, and the temperature everywhere would climb toward the searing heat of the earliest universe. The structures we know would be undone, not by tearing but by compression, melted back into a hot and uniform state. And at the very end, everything, all the matter and energy of the entire cosmos, would be drawn together into a single point of unimaginable density and heat, a mirror of the singularity from which the universe is thought to have sprung. The story would close precisely where it opened. There is a curious detail about a closed and contracting universe worth touching gently, because it shows how different such a cosmos would feel from our own. In a universe curved back on itself and drawing together, light would no longer simply travel outward forever. It could, in principle, curve around the whole of space and return, the way a traveler walking always forward across the surface of a sphere comes back at last to where they began. An observer in the late stages of such a universe might see the same distant galaxy in more than one direction at once, its light having taken different paths around the closing cosmos. The sky of a contracting universe would be a stranger and more folded place than ours, its light gathering back inward as space itself grew small. And the warmth of such a universe would climb steadily as it fell, until the whole sky glowed. Today, the night between the stars is cold and dark, because space has expanded and cooled for billions of years. In a contracting universe, that cooling would reverse, the ancient background warmth compressing and brightening as space shrank around it, until the space between the stars was no longer dark at all, but filled with a rising glow, and then a heat, and then a brilliance matching the surface of a star. The last generations in a collapsing cosmos would watch their night sky slowly brighten and warm, the dark itself dissolving, as the universe hurried back toward the fierce and uniform blaze it was born in. There is a real beauty in that closing, and it is worth dwelling on gently. The Big Crunch gives the universe the shape of a complete gesture, a breath drawn in and then let out, a thing that returns to its own beginning. Where the freeze simply trails off into endless quiet and the rip races to a scattering, the crunch comes full circle. It is the ending with the most satisfying symmetry, the one that feels most like a story with a proper close. Whatever else may be said of it, it has a quiet completeness that the other endings lack. We should be honest, though, about where the Big Crunch stands today. Our current measurements do not favor it. When we look out at the universe now, we do not see the expansion slowing under the weight of gravity. We see it speeding up, driven by dark energy, moving in exactly the wrong direction for a collapse. And when we measure the shape of space, we find it very close to flat rather than closed. On the evidence we have, the universe seems far more likely to fade or to tear than to fall back together. For a while, the Big Crunch was the leading picture of the end. The discovery that expansion is accelerating quietly moved it to the margins. And yet it cannot be set aside completely, and the reason is, once again, dark energy. Because we do not truly understand what dark energy is, we cannot be certain how it will behave over the enormous spans of the future. If it should someday weaken and reverse, becoming an inward pull instead of an outward push, then the long fall could begin after all, even from a universe that looks, today, as though it will expand forever. The Big Crunch is the ending that waits behind the door, marked "What if the push becomes a pull?" It is unlikely on what we now know. It is not impossible. So we set it in its place beside the others, a possibility held open by our own uncertainty. There is something fitting in the fact that the oldest picture of the end, the one people imagined for so long, turns out to depend on the very same mystery that governs all the rest. Whether the universe freezes, tears, or falls back together, the answer lies with dark energy, with that faint and enormous presence we have only just begun to measure. It is worth understanding why this ending held the imagination for so long, because for decades it seemed the most natural close of all. In those years, the great question was simply whether the universe held enough matter to halt its own expansion. There was even a particular density, a certain amount of matter spread through each patch of space that marked the dividing line. Above it, gravity would eventually win and the universe would fall back together. Below it, the expansion would coast on forever. The whole fate of everything seemed to rest on weighing the cosmos and seeing which side of that line it fell on, and for a long time the answer looked genuinely uncertain, the balance almost even. If the fall did come, its final stages would run the universe's own history in reverse, and there is a symmetry in that worth picturing gently. As everything pressed together and grew hot, the structures built up over the ages would be undone in the opposite order from which they formed. Galaxies would merge, then stars would be unmade, then even atoms would be broken apart by the rising heat, the universe climbing back up through the very stages it once descended, until it neared the searing, uniform density of its earliest instant. The last moments of a collapsing universe would look almost exactly like the first moments of an expanding one, only running the other way, a beginning played backwards toward a close. What changed everything was the discovery that the expansion is not slowing at all, but speeding up, driven by the outward push of dark energy. That single finding moved the Big Crunch from the leading picture of the end to a quiet possibility held in reserve. On the evidence we now have, the universe is not on course to fall back together. And yet, because that outward push is the very thing we least understand, the door has not closed entirely. If the push should ever soften into a pull, the long fall could still begin, even from a cosmos that looks, tonight, as though it will expand forever. But the Big Crunch raises one more question that it cannot answer on its own, and it is a question that opens onto one of the loveliest ideas in all of cosmology. If the universe collapses to a single dense and glowing point, a mirror of its own beginning, then is that point truly the end? Or could it be, instead, another beginning? Could the fall back together become a springing outward once more, a new universe rising where the old one ended? That thought carries us out of the Big Crunch and into the idea of the bounce, and the possibility that the end of everything is not an end at all, but a turning. To that we go next. If the universe can fall all the way back together into a single dense and glowing point, then a natural question follows, and it is one of the gentlest in all of cosmology. Must that point be the end? Or could it be a beginning? For as long as people have imagined the universe collapsing, some have wondered whether the collapse might not stop there, but rebound, springing outward into a new expansion, a new universe rising from the close of the old. This is the idea of the Big Bounce, and the family of cyclic universes it belongs to, and it turns the ending of everything into something more like a turning of a page. In the simplest version of the bounce, a contracting universe does not quite collapse to a true, infinite singularity. Instead, as everything is compressed together, some effect we do not yet fully understand halts the collapse just before that final point, at a state of enormous but finite density, and then reverses it. The universe reaches its smallest, hottest, densest moment, and rather than ending there, bounces, beginning to expand once more. What would have been the death of one universe becomes the birth of the next. The big crunch of the old cosmos becomes the big bang of the new. Extend that idea, and you arrive at a cyclic universe, one that expands and contracts over and over, endlessly. In this picture, our own universe would be only one cycle in a series without beginning or end, each cycle rising from a bounce, spreading out, forming its own stars and galaxies, living its own long life, and then, in time, falling back together to bounce again. There would be no single first moment and no final last one, only an eternal rhythm of expansion and contraction, universe after universe, each complete in itself. The appeal of this idea runs deep, and it is worth naming because it explains why the thought has endured so long. A single beginning raises a hard question. What came before it, and why did it happen at all? A single ending raises a matching one. Is that truly all there is? A cyclic universe softens both questions at once. If the universe has always been turning through its cycles, then there is no first cause to explain and no final end to mourn. The ending of each cosmos is simply the seed of the next. There is a comfort in that shape, an old and human comfort, the same one we find in the turning of seasons and the return of morning after night. There is more than one way that a universe might renew itself, and the ideas here are among the most speculative we will meet tonight, so we hold them lightly, as beautiful possibilities rather than established facts. One family of thought imagines that the universe need not even collapse to be reborn. Instead, it expands and empties completely, exactly as in the Big Freeze, cooling and spreading until it holds only a smooth, featureless drift with no structures left at all. And then, remarkably, that utterly emptied and smoothed out cosmos turns out to be mathematically almost indistinguishable from the hot, dense, smooth state of a brand new beginning. In this view, the extreme old age of one universe is quietly the same thing as the infancy of the next. The end does not lead to the beginning through a crush, but through a kind of forgetting, the universe growing so old and so smooth that it becomes young again. Another family of ideas imagines our universe as something like a great sheet or membrane floating in a larger space that holds other sheets alongside it. In these pictures, a new expansion is set off, not by a collapse, but by two such sheets drifting together and gently touching, the contact pouring energy into each and igniting a fresh beginning. The cycle, in this telling, is the slow separation and return of these sheets, each meeting kindling a new universe upon them. It is an idea far removed from anything we can see or test directly, and it belongs firmly in the country of the speculative. But it is one more way the cosmos might renew itself, one more shape the turning might take. There is a genuine obstacle that every cyclic picture has to overcome, and it is worth understanding gently, because it is the same idea we began the night with. Entropy tends to increase, always, in every process. So a naive cycle of expansions and contractions would carry the disorder of one universe forward into the next, each cycle beginning more spread out and worn than the last, until the cycles could no longer properly begin at all. Any serious cyclic model has to find some way around this, some means by which each new universe starts fresh and ordered, rather than inheriting the accumulated disorder of all the cycles before. The more elegant proposals achieve this by having the universe grow so enormous and so smooth before its renewal that the disorder is, in effect, diluted away to nothing, spread so thin across so much space that the next beginning starts clean. This is part of what makes the emptying into a new beginning idea so appealing to those who study it, because it turns the very completeness of the big freeze into the reset the cycle needs. A universe that has spread out utterly, cooled utterly, and smoothed itself into perfect evenness has, in doing so, erased nearly every trace of its own history. It has become featureless, and featurelessness is exactly how a fresh, ordered beginning looks. In this view, the extreme old age of the cosmos is not a barrier to renewal, but the mechanism of it, the universe growing so thoroughly finished that finishing and beginning become the same smooth state. None of this is settled, and it is important to keep these ideas at the arm's length they deserve, held as possibilities rather than findings. We cannot see before our own beginning, and we cannot see past our own ending, and so the cyclic picture may always remain partly a matter of reasoning and hope rather than direct evidence. But the fact that careful thinkers keep returning to it, keep finding ways to make the cycle work, says something about how naturally the mind reaches for renewal over finality, for the turning over the wall. We should be honest that all of these renewing ideas face real difficulties, and none has been confirmed. The great obstacle is the very thing we keep returning to. The expansion of our universe is not slowing, but accelerating, which makes a straightforward collapse and bounce hard to arrange. The models that get around this have to work carefully, and the questions of how a bounce could actually happen, and how each cycle would relate to the one before, remain open and unsettled. These are not predictions we can lean on. They are possibilities we can hold. And yet the cyclic idea endures, and perhaps that endurance says something worth noticing. It endures partly because it answers a longing as much as a question. There is something in us that resists the thought of a single, final ending, and reaches instead for the hope that whatever closes might also, somehow, open again. Whether or not the universe truly bounces, the idea has a quiet power, because it reframes every other ending we have discussed. It suggests that the cold stillness of the freeze, or the scattering of the rip, or the crush of the crunch, might not be the last word after all, but a threshold, a low and quiet place from which something new could rise. Picture it that way for a moment, gently. Picture the very end of a universe, the last black hole gone, the last light spread thin, the whole cosmos smoothed to an even and silent calm. And then picture that calm, after an unmeasurable stretch of time, not simply persisting forever, but somehow tipping over, quietly, into the first faint warmth of a new beginning, a new expansion, new light gathering in a new dark, new stars forming in galaxies that no one from before could ever know. In the cyclic picture, the end of everything is the softest kind of ending there is, because it is not really an end. It is a pause between one universe and the next. Whether reality is truly so kind, we cannot say. The evidence does not yet point clearly to a bounce, and the honest position is one of open uncertainty. But among all the endings we lay side by side tonight, this is the one that carries the most hope folded inside it, and there is no harm in letting it rest gently in the mind. It costs nothing to hold the possibility that the universe, like so much else in nature, moves in cycles, and that even its greatest ending might be only a turning toward a new beginning. Now we come to an ending unlike any other we have seen, one that does not wait on the slow unfolding of expansion or gravity across the ages. It is an ending that could, in principle, begin anywhere, at any time, from a single point, and spread outward through the whole cosmos. It is the strangest of the classic endings, and also, in a certain sense, the most peaceful. It is the change that comes without warning, and it is where we go next. Every ending we have laid down so far unfolds across enormous stretches of time, whole ages of stars and galaxies rising and falling. The ending we turn to now is different in its very nature. It does not wait on the slow spreading of space or the patient pull of gravity. It is the possibility that the universe could be quietly rewritten from within by a change in the character of empty space itself, beginning at a single point and racing outward. It is called vacuum decay, and though it has a reputation as the frightening ending, its most important feature is precisely that no one could ever be frightened by it in advance. To understand it, we have to let go of a comfortable idea, which is that empty space is truly empty. It is not. The vacuum, the seemingly featureless nothing between the stars, is filled everywhere by unseen fields, and those fields give even perfectly empty space a certain baseline amount of energy. This is not a flaw or a rarity. It is simply how the universe is built. And the crucial question, the one on which this ending turns, is whether that baseline energy of empty space is truly at its lowest possible value, or whether it is only resting in a value that is low, but not the lowest. An image helps here, and it is a gentle one. Imagine a ball resting in a small dip partway down a long hillside. The ball is at rest, and it is stable, in the sense that a small nudge will not move it far. But it is not at the very bottom of the hill. There is a deeper valley further down, and if the ball could only get over the small rise that pens it in, it would roll on to that lower place and settle there instead. A universe whose empty space rests in such a dip is stable, but only for now. It sits in what is called a false vacuum, a resting place that is not the true and final lowest one. And a false vacuum, given enough time, does not necessarily stay put. Here is where it becomes more than an abstract picture, because our own measurements place the universe intriguingly close to the edge of this question. When we measure the properties of a certain fundamental field, one woven through all of space, we find values that sit remarkably near the boundary between true stability and this metastable temporary kind. We cannot yet say for certain which side of the line we are on. It is entirely possible that our vacuum is the true and lowest one, perfectly stable, and that this ending simply cannot happen. But it is also possible that we rest in a false vacuum, a long dip on the hillside, stable for now, but not forever. The uncertainty is real, and it is honest. Suppose, then, that we do rest in a false vacuum. What would follow? Somewhere, sometime, in some tiny patch of space, the fields could, by a rare quantum chance, slip over the small rise that pens them in, tunneling through to the deeper valley beyond. In that tiny patch, a bubble of true vacuum would form, a small region where empty space had finally reached its genuine lowest state. And inside that bubble, the laws and constants that govern matter would be subtly, but decisively, different from the ones we know. Different enough that atoms as we understand them, and therefore all ordinary matter, could not hold together in the same way at all. That bubble would not stay small. Because the true vacuum inside it is a lower energy state, the bubble would be driven to grow, its wall sweeping outward and converting the surrounding false vacuum to the new state as it expands. And it would expand extraordinarily fast, its edge racing outward at very nearly the speed of light. This is the feature that makes vacuum decay so strange to contemplate and, in its own way, so gentle. Because the bubble wall travels almost as fast as light itself, it arrives at the very same moment as any light or signal that might have announced it. There is no warning. There is no seeing it come. The change reaches you at precisely the instant that news of it could. There is, in the most literal sense, no dread possible, because there is no time in which to feel it. Sit with that for a moment, because it turns the fearsome picture almost tender. Whatever lay in the path of such a bubble would simply be, and then be part of a different kind of space, with no interval of fear between the two, no approach to watch, no moment of anticipation. Of all the endings we have gathered tonight, this is the one that could never trouble anyone's rest, because its defining quality is that it grants no advance notice at all. The frightening ending is, in the only way that matters to any living thing, the one ending that cannot frighten. And we must be careful to keep its likelihood in proportion, because it is easy to let the vividness of the picture outrun the reality of the odds. Even if our vacuum is the false kind, the chance of such a bubble forming in any given region over any span of time we could picture is thought to be extraordinarily small. The expected wait for such an event, in most estimates, is far longer than the current age of the universe, longer by an enormous factor, so long that in practice it lies among the most remote of all the possibilities. This is not an ending pressing near. It is a faint and distant, maybe, a curiosity about the hidden nature of empty space, far more than a threat to anything we love. There is a reassurance folded into the numbers that is worth drawing out plainly, because it quietly settles most of the unease this idea can stir. The universe has already existed for well over 13 billion years, and in all that time, across the whole of the space we can see, no such bubble has ever formed near us. That long survival is itself a kind of evidence. Whatever the true odds of vacuum decay, they are low enough that an enormous span of time and an enormous volume of space have passed without it happening anywhere within reach. The very fact that we are here, that atoms have held together steadily for billions of years across the visible universe, tells us that this ending, if it can happen at all, is in no hurry whatsoever. It is also worth being clear that the whole scenario rests on a question we have not answered, which is whether our vacuum is truly the false kind at all. The measurements place us near the boundary, but near is not the same as across it. It is entirely possible that empty space is resting in its genuine lowest state, perfectly and permanently stable, in which case the bubble can never form, and this ending simply does not exist for us. We do not yet know. And so vacuum decay sits on the list, not as a looming certainty, but as an open question about the foundations of space, one we hold precisely because we are honest about what we have not yet measured. Even the picture of the bubble itself carries a strange calm when looked at steadily. It would not roar or burn as it came. It would arrive in perfect silence, at the speed of light, converting space to its new form without any of the violence we associate with an ending. And because nothing could outrun it or sense it coming, there would be no fear anywhere ahead of it, no dread, no long approach to endure. Of every ending we have gathered, it is the one that could touch a universe without ever once disturbing its peace beforehand, which is a curious and almost gentle thing to be able to say of the change that rewrites everything. There is something worth appreciating in the very fact that we can ask this question at all, that we can measure the properties of the fields filling empty space closely enough to know that we sit near a boundary, near the edge between a stable vacuum and a metastable one, is itself a quiet wonder. The universe leaves the answer written in the masses of its smallest particles, and we have learned to read just enough of it to know that the question is real and that we do not yet know the answer. That is not a cause for unease. It is a mark of how far our curiosity has reached. So we set vacuum decay in its place among the others, held gently and held lightly. It is the ending that could in principle begin anywhere, that would spread at nearly the speed of light, that would rewrite the rules of matter within its growing bubble, and that, for all its drama, would never grant a single instant of fear to anything in its path. It is the strangest of the classic endings, and in that one specific way, the most merciful. And it reminds us how much still hangs on things we are only beginning to measure, on values balanced near edges we have only lately learned to see. With the 5 great endings now laid side by side, the slow freeze, the tearing rip, the falling crunch, the turning bounce, and this sudden and silent decay, we come to the quieter possibilities that gather at the edges of our knowledge, the endings we cannot yet name, and the honest places where our understanding simply runs out. To those softer uncertainties we turn now. Beyond the 5 great endings lie a scattering of quieter possibilities, and something even more important than any of them, the honest edges of what we know. It would be a kind of pretense to lay out the ways the universe might end without also saying, plainly and gently, that the most truthful answer is that we are not yet certain of any of them. These softer uncertainties belong in the catalogue too, and there is a particular peace in naming them, because they mark the places where careful science and open wonder meet completely. The first and most important thing to say is that we do not fully know how the universe ends, and the reason is always the same. The ending is governed, more than by anything else, by dark energy, and dark energy is the thing we understand least. It makes up the largest share of everything the universe contains, and yet its true nature is almost entirely a mystery to us. We can measure its effects. We can watch it push the expansion faster. But what it actually is, why it exists, and how it will behave across the enormous spans of the future, these remain open. And because they remain open, the ending remains open with them. This is worth holding without discouragement, because it is not ignorance so much as honesty. Every scenario we have described tonight, the freeze, the rip, the crunch, the bounce, the decay, is a carefully reasoned possibility built on the physics we understand today. Not one of them is a settled forecast. They are the shapes the future could take, given what we currently know, and the real answer will depend on measurements not yet made and understanding not yet reached. There is something freeing in that. The end of the universe is not a sentence already written and hidden from us. It is a question still genuinely open, one the cosmos has not yet fully answered, even to itself. There is another gentle possibility that changes the very meaning of the word ending, and it has to do with how large the universe truly is. We can see only a certain distance, out to the edge of the observable universe, the farthest reach from which light has had time to arrive. But the whole universe may extend far beyond that, and it may, for all we can tell, be infinite, stretching on without limit in every direction. If that is so, then the universe as a whole may not have a single ending in the way a finite thing does. Local regions would still fade, or cool, or transform, each patch following its own long path. But there might be no one final moment for everything at once, no single close to the whole. An infinite universe does not end so much as it changes, everywhere, forever, without a last page. Related to this is a subtler thought still, about the ending of time itself, and it flows directly from what we said of heat death. We are used to thinking of time as a stage that goes on regardless, whether or not anything happens upon it. But time, as we actually experience and measure it, is bound up with change, with one moment differing from the next, with events occurring in some order. In a universe that has reached perfect evenness, where nothing gathers and nothing moves and nothing changes, there is no longer anything to distinguish one moment from another. In such a state, some suggest, time in any meaningful sense may effectively come to an end, not because a clock stops ticking, but because there is nothing left for a clock to mark. The end of the universe, in that view, is less an event in time than the quiet closing of time's own relevance. That is a strange and soft idea, and it is best held loosely, but it belongs among the honest possibilities. We might also remember that everything we have said rests on the physics we know now, and that our understanding, for all its reach, is surely incomplete. There are places where our best theories do not yet fit together smoothly, where the behavior of gravity at the smallest scales or the true identity of dark matter and dark energy remain unresolved. A deeper theory, once found, could reveal an ending we have not yet imagined at all, or rule out one we now take seriously, or reshape the whole picture in ways we cannot foresee. The catalogue of endings is not closed. It is open at the far end, and it will likely grow and change as our understanding does. There is a real humility in all of this, and it is a comfortable kind. We are a young species, on a single world, around one ordinary star, in one galaxy among the many, working out the fate of the entire cosmos from the faint clues it leaves us. That we can say anything at all about how the universe ends is remarkable. That we cannot yet say it with certainty is not a failure, but simply where the work has reached. The honest map of the far future has firm coastlines in some places, and, in others, the old and lovely words that mean, "Here our knowledge ends, and wonder begins." And it is worth noticing how gentle these uncertainties feel, compared to the fear the subject might seem to invite. The far future is one of the few places where not knowing carries no danger, because nothing about it presses on us now. We can hold the open questions the way one holds any beautiful unsolved thing, with curiosity rather than unease, turning them over slowly, content to let them stay unanswered a while longer. The universe is under no obligation to have decided its ending yet, and neither are we under any obligation to know it. It is worth being a little more precise about why dark energy leaves the question so open, because the uncertainty is not vague but specific. Dark energy might be a truly constant thing, an unchanging pressure woven into the fabric of empty space itself, the same in every age. If it is, the future is the slow fade of the big freeze, steady and predictable. But dark energy might instead be something more like a field that fills space and can shift over time, weakening in some ages and strengthening in others. If it is that kind of thing, then the future is genuinely undecided, because a field that can change can carry the universe toward a fade, or a tearing, or even, if it should reverse, a fall back together. The whole fork in the road comes down to which of these two natures dark energy truly has, and that is exactly what we have not yet determined. There is a humility in this that is worth sitting with, and it is a comfortable rather than a discouraging one. We are working out the fate of the entire universe from within a single galaxy, over a scant few centuries of careful looking, using the faint light that distant things happen to send our way. That we can narrow the possibilities at all, that we can measure the shape of space and weigh the cosmos and read the behavior of dark energy across billions of years, is a quiet marvel. That we cannot yet close the question is simply the honest condition of a young science looking at the oldest and largest thing there is. And it is worth remembering that the far future is genuinely a place where new understanding could change the whole account. Every scenario tonight is built on the physics we know now, and our knowledge, for all its reach, is unfinished. There are seams in it, places where our best descriptions of gravity and of the very small do not yet meet cleanly, and a deeper theory that joined them could reveal an ending none of us have imagined, or gently retire one we now take seriously. The map of the far future has firm coastlines in some places, and, in others, the honest blank where knowledge ends and patient wonder begins. So we let these quieter possibilities take their places beside the grand ones, and the picture grows fuller for having them. There may be an ending we cannot yet name. The universe may be infinite and have no single close. Time itself may quietly lose its meaning in the final evenness. New understanding may remake the whole account. All of these are held lightly as the soft and open edges of the catalogue. And having named them, we can turn to the practical and quietly moving question of how, from where we stand, we read any of this at all, how the deepest future is written into the present moment, waiting to be measured. To that we go now. There is something quietly moving in the fact that the deepest future is not hidden from us behind some wall of time. It is written, faintly, into the universe as it is right now, encoded in the light of distant galaxies and the masses of tiny particles, waiting to be read. Astronomers do not learn the far future by imagining it or guessing at it. They measure the universe in the present as carefully as they can, and then follow the physics forward. The end of everything is, in a real sense, already legible in the sky above you tonight, for those who know how to look. The most important thing to measure, as we have said again and again, is dark energy, because it holds the master key to which ending comes. And the way we study it is to look back across cosmic history and watch how the expansion of the universe has changed over time. Light from distant galaxies is old light, having traveled for billions of years to reach us, so to look far away is also to look far into the past. By mapping how the expansion behaved long ago and comparing it to how it behaves now, we can begin to tell whether dark energy has held steady, or strengthened, or weakened over the ages. That single trend is the difference between a freeze and a rip, between an endless fade and a great tearing. This is why some of the largest efforts in all of science are devoted to charting the positions of galaxies, patiently, across enormous stretches of sky and time. Surveys map the locations of many millions of galaxies, building a three-dimensional picture of how matter is arranged across billions of years of the universe's history. Woven into that arrangement are subtle patterns, gentle regularities in how galaxies are spaced, that act as a kind of ruler laid across cosmic time. By reading how that ruler has stretched at different epochs, we measure the history of the expansion, and through it, the behavior of dark energy. It is painstaking work, gathering the faint light of countless distant galaxies, and it is, in effect, an attempt to read the ending of the universe in the arrangement of its stars. The second thing we measure is the shape of space, its curvature, and here the news is settled enough to shift the odds. When we study the oldest light in the universe, the faint background glow left over from its early hot phase, we can read in it the geometry of space across the largest scales. And what it tells us, consistently, is that the universe is very close to flat. It is not curved back on itself in the way a closed universe would be. This matters for the ending, because only a closed universe could collapse back together under its own weight without any help. A flat or open universe will simply expand forever, unless dark energy intervenes to change the story. Flatness alone, then, tilts the balance away from the big crunch and toward the freeze or the rip, and it is one of the firmer things we know. The third thing we read is subtler and smaller, and it concerns the stability of empty space, the question behind vacuum decay. And when we do, we find those values sitting near the boundary between a stable vacuum and a metastable one, near enough that we cannot yet say for certain which side we are on. It is a quiet thing, to weigh a few tiny particles in our instruments and find in their masses a clue to whether empty space itself is truly at rest. But that is what it is. The stability of the entire cosmos is encoded in numbers we read from the smallest things we can study. Set these three readings together, and a rough picture emerges, though a humble one. Space is flat, which makes an unaided collapse unlikely. The expansion is accelerating, driven by dark energy, which points away from a crunch and toward a fade or a tearing. And whether that fade or that tearing is our fate depends on the still uncertain behavior of dark energy over time, with a faint recent hint that it may not be perfectly constant. The stability of the vacuum stays an open question, keeping the sudden ending faintly on the list. This is not a final answer. It is the state of the reading so far, and it will sharpen as the measurements improve. What is worth holding on to, though, more than any particular scenario, is the scale of the times involved, because it is the scale that turns fear into wonder. The endings we have described do not merely lie in the future. They lie unimaginably far in the future, past every span we are used to. Our own sun has billions of years of steady light still ahead of it before it even begins to change. And the endings of the universe lie far beyond that, tens of billions of years away at the very soonest, in the case of a rip, and in the case of the freeze, spans so long that the numbers stop being quantities and become almost ideas. Every one of these endings is separated from us by more time than has passed since the beginning of the universe itself, and in most cases by an amount of time so much greater that the comparison loses all meaning. Let that distance settle over you gently, because it is the truest thing about all of it. Between us and the coldest heat death, or the great tearing, or the long fall back together, there lie not only ages but the entire future history of stars, of worlds, of whatever life the cosmos has yet to bring forth. The whole story of everything we know and love, the whole history of the earth and its life, is a single bright moment very near the beginning of the universe's long life. The endings are real. They are also so far away that they belong to a cosmos utterly unlike the crowded, luminous one we live in now. It is worth describing that galaxy mapping a little more fully, because it is one of the most patient and beautiful undertakings in all of science. In the early universe, gentle pressure waves rippled through the hot material that filled space, and when the universe cooled and those waves froze into place, they left a faint, regular scale imprinted on how matter is spread, a preferred distance at which galaxies are very slightly more likely to be found near one another. That distance is known, and it serves as a fixed measuring rod laid down across the cosmos. By finding how large that rod appears at different distances, and therefore at different ages of the universe, astronomers can chart precisely how much space has stretched at each epoch, and so read the whole history of the expansion. It is a way of measuring the growth of the universe using a ruler the early universe itself left behind. There are other rulers and other lamps that help as well, and together they build the picture. Certain kinds of dying stars flare with a brightness so consistent that their true output is known, so that by comparing how bright they truly are with how bright they appear, their distance can be read, and with it the expansion at the time their light set out. Layer these methods together, the frozen ripple and the reliable lamps and the geometry written in the oldest light, and a consistent history of the expansion emerges, detailed enough to begin asking the finest question of all, whether the push of dark energy has held perfectly steady across the ages or shifted by some small amount. That question, still being sharpened, is the one whose answer chooses among the endings. What holds all of these methods together is a single quiet idea, that the future is legible in the present if we measure the present carefully enough. We are not guessing at the fate of the universe. We are reading it, slowly, from the arrangement of galaxies and the brightness of distant stars, and the faint warmth of the beginning, following the physics forward from what we can see now toward what must eventually come. It is painstaking, and it is incomplete, and it is one of the most remarkable things our species does, to sit beneath the sky and work out, from its faint present clues, how the whole of it will one day end. And so the reading of the future, for all that it points toward endings, returns us in the end to the present and to a kind of gratitude. We can measure the fate of the universe because we live at a time when the universe is still readable, still full of galaxies and light and clues, still willing to tell us where it came from and where it may be going. That will not always be so. Far in the future, as we saw, the evidence will fade past reach, and the universe will hide its own story. But now, in this early, bright, generous age, the far future lies open to anyone patient enough to read it in the light of distant galaxies and the mass of tiny things. There is a quiet privilege in that, and it carries us naturally toward the last thing to be said tonight, the long view and the peace that can be found in it. We have laid them all side by side now, the many ways the universe could end. The slow and endless fade of the Big Freeze, with its dying stars and its long reign of black holes and its final, even calm. The great tearing of the Big Rip, where expansion wins so completely it undoes an atom. The long fall back together of the Big Crunch, the story closing where it opened. The turning of the bounce, where an ending becomes a beginning again. The sudden, silent change of vacuum decay, the ending that grants no warning and so no fear. And the quiet, honest uncertainties gathered at the edges, the endings we cannot yet name. Set out together, they make a strange and beautiful map of the far country of the future. And if you look across that whole map, one quality stands out above all the others, shared by every ending on it. That quality is distance. Not one of these endings is near. Not one of them presses toward us. They are less like fates bearing down, and more like the far shape of the land seen from a great height, features of a country so distant that we will never travel to it, described only because the mind longs to know the whole of the map it lives within. The endings are real, and they are worth knowing. But their distance is the truest thing about them, and it is the thing to carry with you as the night settles. Consider where we actually stand in the life of the cosmos. The universe is still young. The stars still burn in their countless numbers. The sky is still full of galaxies, still bright, still crowded, still generous with light and energy and possibility. Star formation, though past its peak, still continues all around. New worlds are still forming. Whatever life the universe has yet to bring forth is, for the most part, still ahead of it. We are living, by every honest measure, in the bright early morning of everything, in the first thin chapter of a book whose ending lies unimaginably far past the final page we can read. That is why none of these endings, rightly understood, is a cause for unease. The heat death is not a horror but a rest, the universe finally, completely even and still, having spent its long life spreading its warmth as widely as it could. The crunch is not a catastrophe, but a return, the cosmos folding gently back to the state it was born from. The bounce is not a loss, but a renewal. And even the rip and the sudden decay are, in the end, simply the universe being fully itself, following its own nature all the way to its own conclusion, over spans so long that no star we know tonight would live to see even the first sign of them. Each ending is a kind of completion. None of them asks anything of you now. There is an old comfort available in the very largeness of all this, and it is worth reaching for as your thoughts begin to slow. When a worry feels enormous, it can help to set it beside something truly enormous, and there is nothing more truly enormous than this. The whole future of the universe, all of its possible endings, lies so far beyond this single night that the distance cannot even be properly felt. Whatever weighs on you tonight is held within a moment so early, so brief, so near the bright beginning of things, that the endings of the cosmos have not the faintest bearing on it. The universe will take care of its own conclusion, in its own unhurried time, ages upon ages from now. Tonight, there is nothing for you to carry of it at all. It is a curious kind of peace, to know that everything ends, and to find the knowledge gentle rather than heavy. But that is what the long view offers. To know that the stars will one day fade is also to know that they are shining now. To know that the sky will one day empty is also to know that it is full now, brimming with light that set out toward us across billions of years. To know that the universe has an ending, or several, is to see more clearly how remarkable it is that there is anything at all, here, in this early and luminous age, including you, awake for a moment beneath it, before sleep. There is one more gentle thing to notice as we gather all of this together, and it is perhaps the quietest comfort of all. Every one of these endings, however different in its shape, arrives at some form of stillness. The freeze settles into an even and boundless calm. The crunch returns to the smooth density it began from. The bounce passes through quiet into a new beginning. The rip, after its brief tearing, leaves only smoothness stretched without limit. Even the silent bubble of vacuum decay brings in its way a new and settled state. The universe, whichever road it takes, is moving toward rest. Its whole long story, in every telling, ends not in struggle but in quiet, and there is something deeply calming in knowing that the destination, by every path, is peace. And it is worth holding too how little any of it touches this night. The soonest of these endings lies tens of billions of years ahead, and most of them lie further still, past spans of time so long they cannot be felt. Between now and then stand the whole future lives of the stars, the forming of countless worlds, and whatever the universe has yet to make. We sit near the very beginning of all of that, in the first bright pages of a story whose ending is written so far ahead that the ink has not been imagined, let alone dried. The endings are true, and they are gentle, and above all they are far, and their farness is a kind of tenderness the universe offers to everything living now. So let the whole enormous future grow soft and distant now. Let the dying of the last stars, and the leaking of the final black holes, and the great tearing, and the long fall, and the silent bubble that never comes, all drift far away, where they belong, at the very end of a road longer than the mind can walk. None of it is close. None of it is tonight. Tonight the universe is young and full and quietly turning, and you are here within it, held safely in its bright first morning, with nothing to do but rest. And so we leave the universe to its long, unhurried ending, whichever way it finally comes to rest. The stars have not begun to tire. The galaxies still fill the dark. Whatever the far future holds, it is so distant that it asks nothing of us at all, and there is a deep and gentle comfort in that, a comfort large enough to sleep inside. Let your breathing slow. Let the whole enormous future grow soft and dim and far away. Let the weight of the day lift gently from your shoulders and drift off into the quiet. Rest now. Sleep well, and good night.